Hi everyone, I'm Satvik from CSCC, currently pursuing BTech in BBIT. Today, I'd like to explain a very important topic in design and analysis of algorithms. Let me share my screen. Today, our topic refers to a very important algorithm, a branch and bound approach. Uh, in this approach, wait a minute. The term branch and bound refers to all the state space search methods in which all children of the E node are generated from any other live node can become a E node. In branch and bound, BFS like space search will be called as FIFO search as the list of live nodes is a first in first out list. It can also called as a queue data structure. A DFS like state space search will be called LIFO, last in first out, which refers to the stack database data structure search as the list of live nodes in the last in is a last in first out list. Some of the terminologies regarding tree organization of solution space. Problem state. Each node in the tree defines a problem state space. All paths from the root to other nodes define the state space of the problem. Solution states. Solution states are those problem states for which the path from the root to to the solution defines a tuple in the solution space. Answer states. Answer states are those solution states for which the path from the root to S defines a tuple that is a member of the set of the solutions. State space tree. The tree organization of the solution space is referred to as the state space tree. Live node. A node which has been generated and whose of all children have not yet been generated is called a live node. There are no children to this live node. It is being generated by another E-node. A live node whose children are currently being generated is called E-node. That is the current execution node is called as an E-node and it generates the children at that particular instance. A dead node. A dead node is generated node which has not been expanded for which cannot be expanded further or all whose children have been generated. P for branch and bound search. Here we can observe it clearly that first the root node is 1. It generates children 2, 3, and 4. We are using FIFO in the sense first in, first out. The first element which is inserted into the queue is 2. So first we are going to expand 2. So 5, 6 nodes are generated from the 2. And the second element in the queue is 3. After 2, we are going to expand 3. So 7, 8 are going to be expanded from 3 and then from 4. After that, the queue is in the queue, the first element is 5. So we expand 5, the node 5. The leaves generated that is 10 and 11. After that, 6. And we assume that there are no more children for 7, 8, and 9, 10, 11, and 12. So these are going to be the leaf nodes. Let us assume that node 12 is the answer code in FIFO. First, we search with the nodes, that is E node. The E node becomes 1. We generate the children of the node 1. We'll place all the live nodes in the queue. That is 2, 3, and 4. Now we are deleting an element from the queue, that is node 2. Next to node 2 becomes the E node and generates its children and places those live nodes in queue. Next, they delete an element from the queue and considering it as E node, that is E node is 3, and its children is generated 7 and 8. The children of 3 and these live nodes are killed by bounding functions. So we will not include in queue. So the queue becomes 4, 5, and 6. Again, deleting an element from the queue, considering it as E node, generating the children for the node 4. Node 9 is generated and killed by bounding function. Again, deleting an element from queue generates children of node 5, that is nodes 10 and 11 are generated and killed by the bounding function. Last node in the queue is 6. Now the child of 6 is 12 and it satisfies the condition of the problem, which is the answer node. The search terms. This is FIFO branching bound. And coming to the last in first out, if we consider the last in first out, firstly the fourth node is going to be expanded, and then the 9 is going to be checked whether the children are present to that node or not. If not, then it comes to the node 3. Node 3 is going to be expanded and then to the node 2. In node 2, the node 6 is going to be checked first, and then for 12, and then to the 5, 11, and then to 10. This process continues in LIFO. The main difference between them is if the node which is to extreme right is the solution, then LIFO works faster, and if it is left, then FIFO works faster. Thank you.